In the vastness of our solar system, beyond the warmth of the inner planets and the familiar glow of the sun, floats a moon that, at first glance, seems quiet, frozen, and lifeless. But if we could peel back its icy shell, beneath that silent exterior, we might find something extraordinary. An ocean so deep it holds more water than all of Earth's seas. A dark world warmed not by sunlight, but by the relentless tug of Jupiter's gravity. A place that may harbor alien life, not as fantasy, but as a real scientific possibility. This is Europa, and it could be the most important place we've never been. But what NASA is now hinting about Europa's hidden ocean could change how we see life beyond Earth forever. Today on Orbital Vistas, we go deep beneath the ice to uncover the truth about Europa and the question humanity has been asking for centuries. Could we really find life out there? And are we truly ready for answers? Europa was first observed over 400 years ago, in 1610 by Galileo Galilei, along with 3 other moons: Io, Ganymede, and Callisto. It became known as one of the Galilean moons of Jupiter. But for centuries, Europa was simply a faint icy speck in a telescope. It wasn't until the late 20th century that this mysterious moon revealed its deeper secrets. In 1979, NASA's Voyager 1 and 2 spacecraft flew by the Jupiter system. As Europa came into focus, astronomers saw something stunning. Its surface wasn't like our moon. It wasn't dusty or cratered or dry. It was smooth, almost eerily smooth, crisscrossed with reddish-brown cracks, ridges and bands. Europa looked like a shattered marble that had been put back together. No towering volcanoes, no massive impact basins. Just ice, endless ice, and the haunting suggestions that something was moving beneath it. This was the first clue that Europa might not be just another frozen rock, but a dynamic world with hidden activity below the surface. Let's dig deeper. In the 1990s, NASA's Galileo spacecraft entered orbit around Jupiter and made 12 flybys of Europa. What it discovered changed everything. Galileo detected fluctuating magnetic fields around Europa, something unexpected. These anomalies suggested the presence of a conductive layer beneath the surface. Salt water is a natural conductor, and the signals were clear. Europa likely had a subsurface ocean, rich with minerals and stretching around the entire moon. But that wasn't all. The surface was found to be relatively young, geologically speaking, just 40 to 90 million years old. This suggests active resurfacing, ice plates shifting and cracking, perhaps due to internal heat or the motion of liquid water below. In 2012, the Hubble Space Telescope detected something else. Plumes, jets of water, vapor erupting from Europa's south pole, launching material hundreds of kilometers into space. If confirmed, these plumes could allow spacecraft to sample Europa's ocean without ever landing. And then came another twist. Some of the materials on Europa's surface detected via spectroscopy were consistent with salts and organic compounds. It appeared that whatever was happening below the surface was also reaching up. Europa wasn't just geologically active, it might be biologically promising. Let's pause for a moment and ask, what does life actually need? Not life as we dream it in science fiction films, but microbial life. Simple, robust, hardy organisms capable of surviving in extreme conditions. Life, in its most basic form, requires 1. Liquid water, a solvent to facilitate chemical reactions. 2. Energy, to drive metabolism and build complexity. 3. Chemical building blocks, like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. 4. Time, to evolve, adapt, and survive. Now let's hold Europa up to that checklist. Liquid water? Check. A global saltwater ocean likely exists beneath its ice, possibly 60 to 150 kilometers deep. That's more water than all of Earth's oceans combined. Energy? Check. Europa is heated from within. Gravitational tidal forces from Jupiter flex the moon's interior, generating friction and warmth. This could support hydrothermal vents at the ocean floor, just like on Earth. Chemistry? Check. Spectral analysis of Europa's surface reveals salts, sulfates, and potential organic molecules. Radiations from Jupiter's magnetic fields also creates oxidants on the surface, chemical that, if transported into the ocean, could feed microbial life. Time? Check. Europa has likely had these conditions for billions of years. That's more than enough time for life to emerge and evolve. If conditions on Europa have been stable for eons, the odds tilt in favor of something stirring up in the deep. So what would life on Europa actually be? Let's be honest, we probably won't find mermaids or sea dragons. More likely, would discover extremophiles, microorganisms adapted to survive in harsh environments. On Earth, such organisms thrive deep in the ocean near scalding hydrothermal vents, inside frozen Antarctic lakes, trapped beneath kilometers of ice, in the dark, salty waters beneath Greenland's glaciers, inside rocks deep underground, isolated for millennia. Some bacteria survive without sunlight, using chemosynthesis, converting chemical energy from rock and minerals into biological energy. Europa may have these same systems at play. If you're fascinated by real discoveries like this one, make sure you subscribe right now, because next week we're covering another mysterious NASA revelation that could be even bigger. Imagine chemosynthetic microbes clinging to the sides of hot vents on the ocean floor, gnat-like colonies feeding off dissolved minerals, even simple multicellular creatures like primitive worms drifting through Europa's dark water. And if Europa's ocean is as ancient as we think, who knows how complex that life could become? Evolution has had millions of years to work its magic. There is even the tantalizing thought, what if life on Europa took an entirely different evolutionary path? What if it's based on silicon instead of carbon? What if it uses ammonia instead of water? That's the real mystery. Not just it's their life, but what kind of life? Europa isn't just theory anymore. We're going there. NASA's Europa Clipper is scheduled to launch soon and arrive in the 2030s. It will orbit Jupiter and make dozens of close flybys of Europa, each time gathering high-resolution data from just 25 kilometers above the surface. Its mission? Find out whether Europa's ocean can support life. The Clipper will, number 1, map the surface in unprecedented detail. Number 2, analyze surface chemistry for signs of organics. Number 3, scan the ice shell with radar to detect sub-ice lakes and pockets. Number 4, fly through plumes if they erupt and collect samples. It's one of the most ambitious planetary science missions ever attempted. But Clipper is just the beginning. ESA's JUICE mission, Jupiter Icy Moon Explorer, is also en route. Though primarily focused on Ganymede, JUICE will make multiple flybys of Europa and gather complementary data. And beyond that, concept missions are in early design stages. Cryobots that could melt through the ice and release swimming drones in the ocean. Lander missions equipped with robotic arms, spectrometers, and microscopes. AI-guided submarines designed to explore the alien abyss and beam back data. These won't launch for decades, but the idea is already alive. For all the excitement around Europa, we must recognize the sheer difficulty of its mission. Challenge number 1, radiation. Europa orbits deep within Jupiter's powerful magnetic field, exposing it to extreme levels of ionizing radiation. In just one day, the surface of Europa receives a radiation dose thousands of times higher than the recommended human limit. That means any spacecraft or future lander needs radiation shielding just to survive a brief visit. Number 2, surface hazards. Europa's surface is jagged, fractured, and unpredictable. It's not a smooth, snowy plain. It's a chaotic ice space, filled with ridges, double ridges, chaos terrain, and blocks of ice floating like tectonic plates. Landing a spacecraft safely on this kind of surface is a feat of engineering. Challenge number 3, drilling through the ice. To actually sample Europa's ocean directly, we'd need to drill through anywhere from 15 to 25 kilometers of solid ice. That's like boring through the entire atmosphere of Earth, plus a bit more, for a robot in deep space with zero human help. The energy required alone is staggering, and keeping a cryobot operational, transmitting data, and sterilized to avoid contamination, that's next level science. Challenge number 4, planetary protection. And here's a moral dilemma. What if we accidentally contaminate Europa? We don't want to introduce Earth microbes into a potentially pristine alien biosphere. If we're not careful, we could destroy or alter Europa's native ecosystem if it exists before we even study it. That's why planetary protection protocols are so strict. Every screw, every circuit board must be baked, scrubbed, and sterilized. We must explore without interfering, because this isn't just science, it's stewardship. Let's fast forward. Imagine it's the 2040s. A robotic lander touches down on Europa's surface. It samples a fresh plume deposit, analyzes it, and the instruments detect something shocking. Complex organic molecules, maybe amino acids, maybe lipid membranes, maybe microbial activity. A signal faint but unmistakable. Life confirmed. The moment is broadcast across Earth. Every screen flashes the news. NASA confirmed extraterrestrial life on Europa. People cry, scientists scream, philosophers weep. The world changes. Because if life exists on Europa, completely separate from Earth, it means life isn't unique. It means biology might be a universal consequences of physics and chemistry. It means the universe is biogenic, life-forming. Think about that. Mars could have once had life. Titan and Enceladus might have life right now. Venus, in its upper clouds, could harbor floating microbes. The implications stretch beyond biology. Does life imply intelligence? Could complex evolution happen elsewhere? Could we one day talk to someone out there? Religions would wrestle with the discovery. Societies would shift focus from wars and politics to the stars. Finding life on Europa would be the beginning of something much bigger. And if you thought Europa might hide alien life, wait until you see what NASA has recently discovered on Enceladus. Watch that video next. It's mind-blowing. Europa isn't just a moon. It's a mirror, a reflection of the unknown. A reminder that beneath still surfaces, life may stir. For now, Europa remains quiet. Its icy crust hides all secrets. But soon, our machines will arrive. Our eyes will peer through the ice. And if we're lucky, the silence will end. Because what we're really searching for isn't just alien life. We're searching for connection, for validation, for proof that we are not alone in this vast, cold universe. Europa could be the first voice to answer back. And when that voice speaks, whether it's through chemistry, biology, or something entirely new, we must be ready. Ready to listen, ready to learn, ready to rewrite everything. Thanks for watching Orbital Vistas, where we journey beyond the stars and dive beneath the ice. If this episode sparked your imagination, hit that like button, subscribe for more space documentaries, and drop a comment below. Do you think there's a life on Europa? If you find it, what next? Until next time, stay curious, stay cosmic, and never stop looking up.